Hey, this is Professor Hamilton. I want to take a few minutes here and run through the PowerPoints for the first chapter. A fair amount of this material will be pretty familiar just from your work experience or classes or maybe just common sense, but I wanted to highlight a few things in this chapter, and so I um, won't cover every point or even slide, but let me try to hit some of the high points here. So here's the learning objectives, and again, some of this, the course itself is a hybrid between how do we use these kind of economic theories, so to speak, and bring it into this practical, well, I'm a manager or I'm a business person in some capacity, and I'd like to figure out how to make some decisions using economics or logic, maybe more commonly stated. Again, a lot of this is pretty self-explanatory. I mean, there's always different definitions or ways we could elaborate. Let me jump down a few slides here to, yeah, this slide. So this is kind of maybe a little overwhelming in that there's all these arrows and boxes and what have you here, but I think it gives kind of a good sense of what managerial economics is about. And the way I even simplify this is I think of it kind of in these splits between, well, there's the input decisions and the output decisions. Who are you going to hire? What are your raw materials going to be, as well as the prices and wages for those inputs? And then the other half of your outputs. Usually there seems to be more of a focus on that in some people's minds. What price are we going to charge? What is the quality of our product? How do we compete within our niche or what have you? So again, no reason to memorize these kind of ideas, but just looking through it, I think will give you some of the ideas of how strategy and decision points arise. Sometimes pretty obviously, but sometimes a little more subtly. Things like reputation or economies of scale. So, right. Understand incentives, understand markets. Okay. This isn't a finance course, and in business analytics, I teach that course usually in the summer for MBAs. So some of you, I think, have had it. Some as undergraduates would have had a similar course. If so, most of you are already pretty familiar with time value of money, present value, and future value. The one thing that I like to emphasize, and usually I start with future value because most people can think forward better than backwards, but you can use this one equation to solve any um, time value of money problem. So even if you have 100 or hundreds or thousands of different data points, even if the interest rate changes from year to year, you can break up a big problem and solve it this way. So this is kind of an example of that. If you had, if you're looking at, say, n, again, kind of mathematical, let's just say 3 for our purposes, 3 future values, you could take each one of those in turn, discount them back to the present, and come up with an answer. So there's a few questions in the chapter about that, and again, we're not turning this into a finance course, so but there'll be a little bit of practice on the homeworks, I believe, with that. Okay, here's a few other examples. Net present value is essentially just that, taking the benefits, subtracting off the cost, all potentially in the future, and bringing them into one number. So in my undergraduate class, I call this squashonomics, squashing all these various numbers in the future and bringing it down into one summary number, NPV in this case. The chapter goes on. Again, I don't necessarily like this, but we'll go with what the authors have done. They wrote the book, so and that is a little bit more on this. So if you have a perpetuity, which sounds a little bit odd because almost everything ends at some point, but usually an assumption of a corporation or hopefully any business is that it's going to have an indefinite life. And even if it's not 1,000 years, it's going to be decades, not just 3 years and then to close the doors, which does happen. So there's this nice formula that if we have an infinite, it kind of sounds strange logically that it would have a present value if you have an infinite number of cash flows. But because of discounting, those future cash flows eventually are tiny. So you just have this present value is the constant cash flow divided by the interest rate. So as is very common in finance, at least for starters, we have these kind of nice models where cash flow is the same every year. In this case, the interest rate is the same every year. In practice, you could get more random or varying amounts there. So, okay. Again, this gets into a little bit more than we need right now in terms of finding present values, but they generate another formula if it's a growing present value. So that's one kind of, economics is a lot about models, not the attractive type, unless you consider math attractive. But the idea that we simplify reality, so we make assumptions about the future, about interest rates and what have you, and in practice, well, maybe we don't expect profits to grow by exactly G% every year, but as an approximation, at least we can get a quick answer using this formula here. So. There is one or two questions in the homework using marginal analysis, and this is basically net present value. Sometimes it's not, doesn't need to be present value, it's just cost versus benefit. And kind of back to a point I started on earlier, I don't think I quite finished my thought, is one reason I think people find economics really challenging is because they're too smart. They're thinking about, well, what about this and that, or where did this formula come from? Let's see if we got one on the next page here. Okay, yes, here's one, for example. The benefit is 250q minus 4q squared. And this is where, for those people of faith especially, we can kind of use this here. It's not necessarily a blind faith, maybe more so in economics than anywhere else. But yeah, maybe this comes from some other demand curve, which we also made an assumption about. But the idea here is to focus on what's given, even though, again, if you're really thinking realistically about the situation, well, there's other benefits or there's other complications. How do we know this formula? But we take what's given and we run with it. Okay. One thing I was just talking to one student about this is that the ideal way to do mathematical optimization is often using calculus, and some of you will have had it, some of you will have had it and remember it, and some won't, and some will have never had it and just have no desire to become a calculus math whiz. So but if you know a little bit of calculus here, it's things like first derivative, pretty simple formulas that allow us to go from benefits to marginal benefits. But here's just a simple example. I think in some ways it's better even to and you can't always do this as quickly, set it up in a spreadsheet, either Excel or I like Google Sheets. It's a little easier for sharing and it's in the cloud kind of thing. That way you can actually try, it's kind of a trial and error method and maybe a little more intuitive in the end rather than, not that the calculus is wrong, but kind of gives you an overview that rather than just zeroing in on solving some formulas. Okay. All right. So here's a little bit of the calculus for those that are interested, but again, by no means do you need to grasp or even look at the calculus if that's not your cup of tea. Okay. The last couple points here are really pivotal and to managerial economics and economics in general. and that is when we look at the cost versus benefit. In general, we would say yes, the benefits need to outweigh the cost for a decision to be good. And another way of kind of stating that is the marginal benefits. So if I take a step in one direction, if I hire a person, did their value added to the company outweigh the cost of compensation and training and what have you? So, so that's a fundamental rule. We'll see some of that, I believe, in the homework. Okay. Last slide. Well, of course, practice, practice. Don't get too stressed on the homeworks. We'll go through those each week, and I'll actually go ahead and post some of the at least partial solutions. And it's going to be a good course. Okay, I'm gonna look out for you, and you're going to look out for me too, I hope. So that's it for chapter 1. Of course, I'd like you to read the chapter. I know some people rely on PowerPoints, but I think if you read the chapter, you'll fill in some of these details, and things will go better rather than maybe jumping too quickly into, say, the homeworks. But pick your style. Some people like to do that. Challenge themselves with the questions and then go back and figure out stuff from the book. All right, looking forward to the course. See you soon.